Hello and welcome back to another episode of JaRu, Effective JaRu, where we read effective Java and see how the individual items translate from the Java world to the Rust world. Most often, there's not a direct match here because the languages are quite different, and you really see what difference it makes if you enforce certain rules to the writability or mutability of your objects, as is the case in Rust and not so much actually in Java. Also how to deal with static or global objects and singletons and stuff, which is a huge source for problems in multi-threaded programs. So yeah, item 4 is something I haven't had a look at, and it's really just one way to make sure a utility type cannot be instantiated unless it's by yourself in some way. Actually, I'm not sure how this can then work if you can't even do it yourself. Interesting. So I'm not sure. Maybe I should read up on this. Where is the utility type? Here. But making an abstract type doesn't work. Is this abstract? No. So this basically makes sure this is never being created. Probably this is useful if you want to have just static methods on it. Then, it makes sense. I think this is what this tries to make or to emphasize here. However, if you have only static methods, maybe you want to have just functions, and take a more functional approach. On the other hand, having a class is not bad because other people could possibly subclass you and add stuff, extend you. So in Python, I usually prefer to have a class over module level functions for that particular reason. So yeah, probably not too bad, but yeah, in Java, there is no such thing as a function. I think that's all right. I mean, that's a part that is all right. It's just what Java embraces, and that's how it is. So, that said, item 5. So, this is all about not instantiating objects unnecessarily. Where is it? Come on. Here. Avoid creating unnecessary objects because object allocation is expensive. It's heap allocated, and even though all this stuff is optimized as optimized as it gets, it's still expensive compared to a variable that is, or memory that is located on the stack, right? And the good thing is in Rust you have perfect control over it, and there is, all the problems described here, they're always obvious in Rust. If something is expensive, or let's say if something is expensive, you also won't see this if an object is expensive. But you see if it's heap allocated or not, always. Also, you don't necessarily know that it allocates under the hood, which is what a vector does, for instance, but you can let's say you can guess it if you have something that resizes dynamically. Then the heap must be there. But when it comes to individual objects, it's really obvious in Rust what's there and what not. So I want to skip ahead a bit and have a look at this hideously slow program. Can you spot the object creation? Actually, I didn't spot it. I was thinking, damn it, does this create an object each time? No, this is just an integer here, apparently a 32-bit max value. So yeah, in order to make the sum and keep the value, you see that it will store it in a long, which is, for those uninitiated to the magic of Java, it is a 64-bit value. And I think it's really interesting because this is now an object because of the capital L here. And thanks to autoboxing, the boundaries between objects and primitive types, they kind of go away, and it just boxes it and unboxes it on the fly, and you don't see what's happening. This is something that will never happen in Rust. Never, ever. Rust is explicit, and this is just something that won't happen to you. So let's run it. Basically, let's not run it because it heats up my computer, and there's no need. This takes 43 seconds if it's using the auto boxing thing, and 7 seconds on the machine if it's just a primitive version. So let's write this in Rust real quick. I think for that I would just go with the main. So item 05 source main.rs. Then we have fn main. Args you get from the environment, right? So we have nothing else to take care for. Then we have our usize. Well, let's make it a u64. Another nice thing. Let mut sum is a 0 in u64. So that's beautiful because we know exactly what type it is and how what the domain of the type will be. It's a 64-bit unsigned value, whereas this, by the way, is a signed value, so we can hold more than this Java version can. So then we iterate through values. So for for I in, let's have a range here, 0 to how is it? I think std. No, wait. No, actually, I want to have this. So it's u32 std u32 max. I think it's max in this case. And we have to put this into parentheses, I think. So now we iterate through that and we say sum plus equals 1. There we are. And we have to convert this as u64. That's important. And last but not least, let's put it out. std io std out. Right. Yeah, we want to convert this actually, and the simplest thing to do this is to use std io self and write, and now we can just use the write macro to do that. Actually, write line is more what we want here. So now we give it io std out, and the actual number. So the conversion to a string is happening like in the write macro now. And it's all done statically, but there might be an allocation. I'm not sure if this is the best way, the fastest way. I'm not so fond of this version, but I think it should do it as fast as it gets. It doesn't like this. I don't know why. Let's try it though. So let's try to put the sum here, and we have to ignore the return value to make this work. Okay, so there we go. Let's go here, item 05, cargo, run, release, and time. So Rust does it in 3.6 seconds, which is twice as fast as the Java version, and interestingly, the value is a different one, isn't it? So let's try something. I would like to know, if we would use a U32, we would get an overflow, right? Do we detect that overflow at runtime? I think there is overflow checking enabled, so it should panic now, right? No? Not right. So there has been an overflow and we didn't see it. In debug mode, we would see it, right? Yes. Interesting. I wasn't sure yet what Rust does, and if overflow checking is enabled in release mode as well, but it is not, which I think is a terrible decision. I'm not a fan, because that's part of safety, right? And I read about it that it's disabled in release mode, but can you enable it in release mode explicitly? I'm not sure. Rust overflow check release. Is there something? Actually, I want to enable them. What do you say? Which normally run on debug. I mean, you could change the cargo manifest to run them in release. Yeah. But how can I enable them? There are some options you can provide to cargo, but I don't think it's that specific. Why tie overflow checking to debug assertion? Shows that perversive checking for overflow is performed at some point in the development cycle, even if it does not take place in shipping code for performance reasons. See, performance reasons? This should be second, right? In Rust, safety comes first. So if performance has to take a step back, then that's how it is. The goal is to prevent lock-in, whereas code has de facto reliance on wrapping semantics and thus incorrectly breaks when a stricter checking is applied. Yeah, so that's something you would detect in debug mode at least. We would like to allow people to switch perversive overflow checks on by default, for example. However, if the default is not to check for overflow, then it seems likely that a perversive check like that could not be used because libraries are sure to come to rely on wrapping semantics even if accidentally. By making the default for debugging code the checked overflow, we will help ensure that users will encounter overflow errors in practice and thus become aware that overflows in Rust are not the norm. It will also help debug simple errors. Okay, but can I enable it somewhere with cargo? Please. Yeah, so I think this is not... Overflow check, scoped attributed control. Yeah, I don't think that is implemented. Huh. Yeah, I don't see it. Also, Rust language is not tied to cargo at all, so I wouldn't expect to see this here. Maybe I find it in the documentation somewhere. The guide, documentation, manifest. So overflow, nope, Rust C. Debug assertions. Okay, so here we have profile information. Yeah, maybe debug assertions in release mode. Profile release. Maybe we can enforce this. Let's see. So now we have an overflow. That's cool. Interestingly, I think the Java version returns a different value for this, does it? Or am I wrong? Let's run it. I have the feeling this overflows. It will take a while. Let's check the cargo toml in the meanwhile. Say profile release. Spell checking. There we go. Debug assertions true. That is nice. So look at this value here. It's very different from what we have. And they do the same thing. Oh, maybe I... Maybe these values... Oh yeah, U32 is bigger, right? So this must be an I32 to be the same thing. Yeah, so sure, we have an overflow now, but in release mode, we should still have an overflow, right? Cool. So debug assertion is what you want to turn on in release mode as well to have more safety in Rust. And this is something I find very important because sometimes you have long-running server processes and, you know, counters overflow. See these car issues that they have sometimes, right? A counter overflows and then your brakes will not work anymore. And this is something... Well, you wanna know. You just don't want to work with wrong values. You'd rather crash You know, this is how these super safe system works anyway. You have like agents, and if one crashes, you restart it with a clean state. And this is really what you want here. And you don't just want it to run with an overflown value and then stuff goes wrong. Yeah, so let's see what happens here. I would actually put this back to U64. And we put this to U64 as well. And I think it's beautiful that you have to convert the types. You know, there's no auto conversion happening here. So lots of errors or, you know, things that are unclear don't happen that way. Look at that. Now it's even faster because it's less iterations. And in release mode, you know, now we get the same value here as Java, which takes 3.5 times longer. Yeah, actually, I would love to know what it executes there. Can I just, how do I execute with Java C, I guess? How do I execute something? Java C? Let's ask, because I would like to do this manually so that I can time it. Java C execute main or something. Running Java from command prompt. Yeah, this one. How do I run it? I don't know. Java seems to be Windows based, huh? Seems to be, yeah, anyway. So this might explain. You just run it like this, that's all. Okay, cool. I can do that. Java C up, Java, yes, chapter 2, item of 5, and then we have the sum. Oh, I don't think this ran. I think it just compiled it. Yeah, will you? Oh, now I might have to run the class or something. Maybe Java can run the class. But how do I? Okay, so let's keep looking then. JavaC created the hello world class files. Okay. So I guess I can now just call it directly, like so. Why don't I see anything anymore? Why? That's weird. Could not find or load main class. Java org effective Java items, item of 5 sum. No? But I compiled it, did I? Here's the class file. Ah, man. Maybe it's because of the package, huh? And the path and whatnot. Temp path, no, yeah, well, fine. I'm not interested in that. Yeah. Yeah, so I can use Java to run this, but it seems it doesn't like the way I specify the file. Somehow. Okay. Can you tell me what you would do here? Run. Oops. Okay. Aha, it sets the class path. Class path, blah, blah, blah. Effective Java bin. Okay, so that's okay. I see. That's how that works. Okay, so let's run this manually then, and we shall see how fast this is. And yeah, it only needs 1.3 gigabyte. Man, not bad. 6.5 seconds. Really? Did I see this? Is it 1.3 gigabyte? Yeah. Wow, that's crazy. There might be some setting that sets the default heap or something. But it's still crazy. Phew. So that about efficiency that you get by default. So 6.46 by 2.11 or something, huh? So yeah, we are 3 times faster with Rust out of the box. But that's just, that's not a real program. Still, it kind of shows the performance penalty that you take for using Java. Man, that's crazy. If you use Java, you can as well use Go, huh? I mean it, in a way. Honestly, this is... I don't see the real difference there then anymore. Except that Go might be nicer to handle when it comes to concurrent programming. Wow, I didn't expect that. Yeah. If I would, if I would be in a Go path, I would even consider writing that program in Go. But thanks to the way Go is structured, I kind of feel like I don't want to do that right now. But anyway, so that is that. We are 21 minutes in. And yeah, if I change this to long and we have this autoboxing going on, then yeah, I think I want to compile this Java C. Compile this again. Now I have this class file that I want to move elsewhere. Oh no, wait, I can just compile this here. That's easier. Compile the current class. And now I can just actually remove that and rerun my timed Java one, which now uses an object, even though it takes much longer. Yeah, so that's the resident size. No, that's interesting. But I did rebuild it, right? Build the current class, see? So this should take longer. It did take longer before. Well, it doesn't. So let's see, is this about 6 seconds here, or is it 40-ish? That's about 6 seconds. Okay, so apparently there is some optimization going on, huh? Because that's just not happening anymore. Okay. So the book, don't trust the book. It's too old. It's from 2008 already. All right, so that is that. What else? This one here, the slow version. So the book basically says that don't create objects when you don't have to. So what it says is, if it's always the same, if this is static stuff that doesn't change, right? So then you should make it static. And this makes sense everywhere. So the fast version just sticks to that and says, well, we have a few fields that are prepared. And we basically set up these dates. And then we can compare them and see what's going on to determine if this is a baby boomer. And yeah, let's have this interface in idiomatic Rust. I wouldn't, I would just say let's do it as good as we can in Rust right now. And I guess as a library, I would do a functional interface here because there's no need to have an object for this. In the end, it's a date, and why would I don't want to pretend I have a person here. And decoupling this will always be better, I think. So it's a pub if n is baby boomer. And now, it's just a Boolean, right? And now it would be interesting to see what kind of date types we have. And honestly, I don't really know that. I think we should be able... I mean, there's a crate for this at least, and I think this is what you have to do. Yeah, there's a crate. Yeah, that's the Rust world. There's a crate for this, huh? There's an app for this. There's a crate for this with date and date time chrono. Date, the library provides a notion of a calendar. Date, chrono, date and time library for Rust. I mean, let's just go by the downloads here, which seems to be the thing. Documentation. Cool. Cargo toml in item 5. It's smart enough to know what I want. Oh, I have it open as well. So dependencies. Oops. Chrono in any version. That is that. Now we get chrono for our library. Extern crate chrono. Thank you very much. Does it like that? So it's updating the registry, then it's pulling chrono and everything that you need and builds it. So yeah, let's in the meanwhile figure out how we work with dates. Okay, so that's a date time. Is a date including the time? January 1st, so I think yes it does. So the date is date time actually. So let's use it, use chrono date time. Oh yeah, we have to specify, so within the type you bake the time zone, which is pretty cool. It's GMT here that we want, but actually we do any type, right? Why wouldn't we? Yeah, I would go with any type and then see if I can use static somehow. I'm not sure about that, because the static is really well suited for what we want here, possibly, or constants, but I'm not sure if we can do this. So TZ, that's the time zone where TZ is. So how can we define that? Time zone. Yeah, so let's have a date time. Oh, there. Time zone, right? And this is a trait, is it? Cool. And this totally works for us. Is time zone. So we shall import that, or we shall use that as well. Time zone. And here we are. Nice. Oops. Yeah. I don't know how to format this. Never. Let's do it like this, and then we say, well, we take a read-only borrow of a date time TZ with any TZ. We don't care, right? So right now we are already better than this version, provided we can make it work, because we are time zone independent. It's just a question on how we determine, how we must have a conversion then from time zone to time zone, or we hard code it to TMZ somehow. And yeah, by default, maybe I say false here so that this is actually working. Cargo build, cool. And is there a test for this? No, but we can easily write run from 1946 to 65. There is a baby boom. Everybody gets children. So yeah, let's have an extern crate chrono as well. Use chrono date time. That's what we need as well. And time zone. I wonder. Oh, we have UTC and local. Yeah, let's take UTC then, because UTC is, I think, what we want. Universal time code or something. And use item 05. That's okay only in unit test, that you just import everything, I think. So there we can close. So let's have a date time object. Yeah, let's see how this is created. UTC. Ah, that's how it works. Parse from YMD. Okay, so the YMD thing is the constructor for a year and date. I think that's sufficient for us, huh? So we don't need a date time. This will return a date time for us. So yeah, assert that UTC YMD, let's say 1946 year month day, 5 2 whatever is a baby boomer date. So is baby boomer yes, and in any case the current date time UTC now should not be that, right? Like this. Okay, so that should be our test. That should be true. Right now I think one will work, the other one will not. Oh yeah, we don't have library tests, we don't have unit tests here. Test unit. No associated name, item named, command found. Oh. Oh. What is UTC? This is a type, but yeah, let's look. I'm a bit confused. Why does YMD work like that? I thought it was a... Oh no, it's an instance method, but where do I get this UTC instance? Is this a static maybe? Huh? Call me confused. Maybe it's directly in here. UTC something. How does that work? This makes sense to me, but actually this doesn't make sense to me. Unless you create that instance somewhere. Let's try it then. UTC now works, but this... See? Yeah, so we need an instance of that. UTC now. How? Create your own date. Your own date and time is a very bit verbose due to stacks of function method overloading, but in turn you get a rich combination of initialization methods. Well, does that even run? Maybe it does. Maybe I have to import what I need and didn't do it yet. I use chrono UTC. Maybe there are multiple ones. Actually, that's a bit confusing now. Because YMD is definitely an instance method here, which returns a new date. Oh, it also returns a new date, and I think and HMS. So on date you would expect and HMS, which is then a date time. Yeah. Okay, so What would be better here, date time or date? Seems more like date, because the time is not interesting to us anyway. Yeah, so let's use a date here. I think that's the first change I would want to make. What's the time saying? Well, still some left. Good. So we use a date here. Fine. And this is something we easily have now. Also nice. Except for this thing. So we need a UTC instance. Which kind of seems weird that I need a self on this, even though whatever, man. And maybe I don't want to parameterize that. I'm a bit afraid about this, but we will see. We'll see how it goes. Yeah, that's weird. I could do a today and then YMD, but this also seems a bit redundant, does it? No method named YMD on a date. That's true. That's totally true. Why doesn't this work for me? How do I get an instance of a time zone? I don't. That's the thing. I do not get an instance of a time zone. So maybe that's a bit difficult for me right now. Unintuitive, I could say, but maybe I didn't get the gist of it. So if I want to have a date, I can say from naive time, from UTC, I could say, have a naive date here. And how do I get a naive date? So I could say naive date from YMD. And then I can create a UTC date from that. But that also seems a bit too cumbersome, doesn't it? But that would be it. Because this definitely doesn't work. I mean, not for me. Maybe I have. Let's try that. You know what happens if I use everything? Use chrono this. Oh no, wait, actually not here, but here. So does that work now? As advertised. This would mean we get some global instance, some static instance there somehow. Unused variable date. Cool. So now it finds it. Where is that coming from? That's very interesting. Okay, so there is some instance lurking around there somewhere. And I'd like to know where. Let's have a look at the source, UTC. So here it gets it, but is there another one? No, it doesn't seem like it. Offset UTC. That's the one. And it's, I don't know. I really don't know where that is coming from. Huh. This is the most efficient time zone. You don't need local time. Yeah. And there's no static instance to be found here. Maybe it's coming from offset somehow. There was a UTC. Oh, that's a module. Wow. Fair enough. I don't see it. Okay, we are wasting time. I must say I still don't understand this. And I would love to know how I can make this work without importing everything, because that sucks usually. Okay, so that works now. Now we have a type mismatch and whatnot. So expected a chrono date, found chrono date time. Okay. But oh yeah, for the now one, huh? So let's convert a date time to a date time. There must be some way to do it. Should probably be easy. Ah yeah, so that's just date. Now date. I think today is the current date, huh? Okay, cool. So now we have figured out the interface. That was easy. Maybe it's just me being a bit slow in understanding. I would totally consider this. And now it's about implementing that, huh? So that's just a test. So let's create a... Yeah. So explicitly mentioning this in UTC would be a good way. Static... That's constants, right? In a way that should be constant. But I don't know if we can make this work for us. All we want to do is have a date object, and I assume we can compare them properly. Have a date object that is the start of the baby boom. Boom. Start. I don't know. Can I just... Yeah, so in a way I want to have the time zone here. And what can I do with the time zone? Because now I want to use the time zone type and create a matching date object. From self. So I could do from UTC here. And the offset is its own offset. Considering that it implements time zone. So we have a type here. We have our own offset type. Could say from offset, offset from local date, local result. Where's offset from UTC date? Also that we are not interested in. So it's this YMD, but first we need a self instance. Yeah, so why don't we do it? Yeah, so let's see how that works. TZ. From offset, I guess. But what is the offset? From local date, from UTC date, I think we can't really abstract that away, huh? Because the actual offset I cannot access. But maybe this from local date, huh? Because that's then local to the time zone, which could be UTC. So a naive date, I think I could drop in here and it would work. Possibly, maybe. Yeah, so I would actually be tempted to try that. Then we get a local result, which is what? Which is single, ambiguous, or... Yeah, and it implements time zone, so we might be able... Yeah, at the end of the day, we want a date, huh? Local result of a self-offset even. Damn. I want a date. So naive dates are those without a time zone, I suppose. Huh. From offset, yeah. I would love to provide an offset here, but I have no idea how I do this. How do I get an instance? Associated type of this used to store the actual offset in date time, and time times the original time zone value can be recovered via time zone from offset. Yeah. I don't know how this works. Damn it. This is more difficult than I thought. It's not the first time I'm running into this thing. Damn it. Probably it's just me having difficulty getting this right. Yeah, so let's do UTC then. You know, fuck it. Because then I know how to get this date time and we are fine. I don't like this import. So this is definitely something to improve. So I would like to have a static one, which hopefully just gets evaluated once. Then we have 1946 1 1. Does that work? Seems to work. So once the type. You shall have your type. Date UTC. I wonder if this is evaluated only once. Static contains unimplemented expression type. Oh. So that can't be a static then, huh? Probably also not a constant. Nope. So expressions can't be evaluated. It's more like a compile time thing. So no, we can't have statics here. Not like this. I don't think this will work for us. So how can we make this static? I don't think we can at all, huh? Not like that. Yeah, so that's a bad thing in a way, because now we are unable to actually do what Java does. Java is quite powerful when it comes to that because it can evaluate everything in a static, pseudo-static fashion. After all, that's not compile time, it's also runtime evaluated, but it is done only once and you can share it nicely. Yeah. So there it is. Boom start, boom end. We instantiate these things and it has nothing to do with static stuff. We do this on every call, which is a bit annoying. So that should now build. And now it should be between these, huh? So it's date greater or equal, then boom start, and of course boom end is the other one. Copy paste or smaller, or date smaller equal than boom end. This would be the way I would want to write this. Let's see if that works. Oh yeah, sure, we have to dereference it. We have to deref the date because that's a borrow here. And we are done, even though it still doesn't work. And not or. Voila. So that's the implementation in Rust. I mean, honest to God, it's really easy once you have figured out how to use this chrono library. But that's how that works. I don't know. We could do a benchmark, but then I would have to use nightly, unfortunately, because the benchmark stuff is still unstable. I could easily do that, but yeah, that's it. It's very straightforward, and of course not optimized. I don't know how you could make this static. I don't think you can. You could, of course, have an object that initializes these values once and then reuses them accordingly. So I think that's what you would want. A baby boomer structure, a baby boom checker. So it's more like this then. Struct baby boom checker. So this would be faster than start is a date UTC. Then we have an end date UTC. The creation here would be fn new, which returns a baby boom checker. And we shall have a start, which is this. And an end, which is this. This is a private field. We could actually make it public, but then people could override it, so we keep it safe, basically. We could allow access to these fields through some accessors or something, so that we control that it remains read-only, but that is it. Fn, now we have is baby boomer. Yeah, it's mainly this, popfn. Oh, we want to have a popfn here as well. And this is how you would do it, I think. So as static stuff doesn't really work because it's kind of globally accessible, and this poses problems with thread safety. In Rust, you don't do this. So instead, you put everything on instance level and then use the type respectively. So we will redesign this a bit. So let's do it like that. Is baby boomer. We want to have a self. And we can say self start, self end. This is all. And here we would, we could have a even a public function or a type method here that will allow us to do this, or we keep the functional interface is baby boomer, which just creates a checker and then asks if it's a baby boomer or not. So that's exactly the same thing also in terms of cost, even though we can now have an efficient way of doing this, because if you have your own baby boom checker, you can do this and keep these values static, basically, or unchanged. And this is, I think, a cool way to do it. And that's also very clear, if you ask me. But that's also nice. And that's something to remember when doing Java, I think. And yeah, now I am kind of interested in a benchmark. So let's have this real quick. We are 52 minutes in. Benches. Boom checker. So we have the functional one. And all we have to do is put the benchmark code here. Like this. Let's do the extern crate stuff here, and we need chrono as well. So basically that's the boilerplate that we need to copy. And then let's just, no, it doesn't matter. I think the effort is the same. So that is a boomer. Like this, and then it gives you the value or the information about, oh yeah, extern crate test. Then it tells you how many nanosecond it took to do that. So yeah, we should probably also cache this value. Let boomer be this one, so we don't factor that in. So that should be quite a good test to see how fast it is. And then we say boom, test black box, so that the value is used and it's not just optimized away. So yeah, in theory we can do this. Practically we cannot, because it's not stable. So we need to switch to nightly for that. It should be easy enough, but we shall see. And in the meanwhile, we will have the non-functional one. Performance. Implementation. So we have the boomer, we have the checker, which is a baby boom checker. And then we can say, well, baby boom checker is baby boomer. And that's the fast version. We will see what kind of the overhead is. Yeah, use of unstable feature test. I do understand. We don't want that. Bench. Can we specify the bench? Yes. Bench, and then it's just the boom checker. Oh. So it wants to be a pub struct. See, we just found a problem in our API. Good, and now we just want to have the nightly multi-rust override nightly. I didn't update my nightly in a while, but that doesn't matter for that particular purpose. What's my nightly, by the way? Oh, so that's Rust stable, Rust C version. It will tell me eventually. And I would even in another shell update this. But let's first get the benchmarks up and running. Come on, come on, compile. Compile faster if you can. I want to see what the difference is. Yeah, but anyway, that's the fast version. That makes sense because you just don't unnecessarily create otherwise constant values. So that's just common sense in a way. And the question is not whether or not to do it. The question is how you do it in the respective language, how to do it syntactically, basically. And that's all here. Nothing else. So the book, I mean, you know, I've read this here, and that's kind of an interesting show. It also means that the optimization of Java have become better since, because that is not slow anymore. It's just the same as if you would do an unboxed long for some reason. So that's quite interesting. And are you done? Ugh. Yeah, so benchmarking is still no fun. So that's nearly a month old. Yikes. No. Didn't I just add this? Oh, I added it to the wrong one. We want to add it to the boom checker here. Okay. Now it should do something. It does. Cool. So the functional one is 32 nanoseconds, 73 nanoseconds. Okay. And the other one is 8 nanoseconds. So yes, it is considerably slower to create these objects, even though we don't even heap allocate them. So the Rust version would in any case be like so many times faster than the respective Java code. There's no doubt about it. But that's kind of nothing, you know, nothing unexpected here, nothing new here. Cool thing. I think that concludes this episode. I was a bit slow in setting this up here. If I would have followed the instructions in the documentation of Chrono, I wouldn't have had that much trouble, but sometimes I really want to understand what's going on, and this didn't make it easy on me. And I still don't understand where this UTC object is coming from that I'm using here to create new dates. But that shall be it. Very interesting also to see how much nicer this code actually is. You know, less stuff happening here. This is one of the cases where I totally prefer Rust once again. And well, that's just me. Thanks for watching and have a great day.